All right. I thought that we'd play a little. Um, I want you to I want you to be able to make nice plots for your reports, for your lab reports, and just in general, I want you to know how to make some nice plots. Let's get started. So, okay. Well, I could use, a lot of times I just like to type on the command line, but we're going to be doing a bit of changes, so I don't want to clear everything every time, so it's just easier to rerun it, a script. So the first thing I always do is um, write these commands. So clear all clears all the variables in memory. Close all closes all the figures, and CLC clears all the console. So for example, if I start typing things, you can just type CLC. Okay. So that's a nice thing to run, just so we start from scratch. If you don't do the clear all, well, obviously if you don't close all, you have a bunch of figures that keep hanging around. And then clear all, sometimes you think you could forget about a variable that's already in memory and make the mistake of using the wrong variable. So if you clear it, you know you won't accidentally grab anything. All right. So for plotting, we need some time. I guess we'll call it time. It could be anything. We need an x-axis and a y-axis. Um, so I'm going to call time, and I'm going to make a time vector. I'm going to call it t, and I'm going to say that t is between 0 and 10 seconds. But I want this plot to be smooth. So I'm going to make a lot of points in between 10 seconds, 0 and 10 seconds. So there will be about 10,000. There should be 10,000 points or 10,001 points in this time vector. So that should make it nice and smooth. And let's just plot t squared. Okay, just plot a parabola. All right. Hopefully you're comfortable with the dot command, which is element by element operation. You would get an error if we did this, and we can try that. Get an error. You can't take a vector and multiply it by itself unless you transpose. So what we could do, if you were talking about vectors, you could do, you could transpose it, all right, and that'll give you, that would work, okay, but here we don't even want to, but that'll only give you one number. See, y is just, come on, oh no, oops, oh, I did the wrong direction. So I'm going to hit Control C. Okay, that was the outer product rather than the inner product. So I'm going to put, anyway, this is a linear algebra thing. If I did it this way, then I would get the inner product. And you see y is just a number. But anyway, that's not exactly what we want to do. We want to multiply the first element of t times the second element of t, and so on. And that's just easy. If I use either the dot times, and that'll give me my vector y, which is the same number of elements, or I can do dot power 2, which is the same thing. Okay, so I'll put that it's also equal to t times t. Okay, now we have it, so let's plot. So that's easy. So if I plot, you'll see, here we go. All right, we've got the start of a plot. And then I could change, I want you to show right away, I could change it to red. I could also do, so let's do red, or green, or I could do a dash dot. And all of these you can find, if you go help plot, you can find a lot of different ways. See, here's a bunch of different ways you can plot. All right, so I'm just going to leave it off for now. So here we're back. Now, one thing to make a nice plot is the ability to change the line width. Sometimes it's hard to see. This is quite thin. So what you can do is you can just literally go line width, and I do comma 2. Okay, and you'll see something like this, and I think that looks much better. One thing you'll see here is you'll see the text, the font size for the axes are quite small, so we'll try to change that in a little bit. Um, okay, so let's add some more plots on this thing. Let's do a plot that follows this, but with a staircase. All right, so for example, if I go stairs, t comma y, and then I'm going to leave the line width off for a second, except for I'm going to do red. Okay, so let's run that. Oh, I forgot. I need to hold on if I want to plot on top of things. So hold on. That allows me to continue to plot on top. Now if I zoom in, I'm going to zoom way in. Here you go. So you can see way in, you can see this red staircase. All right, so it doesn't, unlike connecting the dots that plot does. Plot actually draws a line between this point and this point. Stair keeps it constant along the delta t and then goes to the next one. Draws a straight, so it draws straight lines, or I should say orthogonal lines. Okay, well, it's hard to see it, so what I want to do is I want to use less points to try to make that look a little bit better. So what I'm going to do is I'm going to actually define a new, well, let's say I define a new T2, and I do it from 0 to 10 by ones, but you don't need 1 to do it by ones. So T2 is that, and Y2 equals T2 dot power squared. Okay, so I'm going to do T2 and Y2. All right, let's draw that. Okay, so now you see, now you can really see the staircase. And because we're using a lot less points, I'm not going across 10,000 points, I'm only going across 11 points. Okay, and you can test that here. You can see the length. Okay, so now one other note I want to make is I could have, so well, I'll leave them, T2. Okay, now I'm gonna make the same points. I'm gonna say T3, but this time I'm gonna find these. I'm gonna try to make the same vector, but by pulling out those points from T and Y directly. So I'm gonna say T3 equals T of the first element and every 1,000 elements after that, because it takes 1,000 of these to get to 1 second. So 1,000 milliseconds will get you a second, basically. All right. So I'm going to run that, and I'll do the same with Y3. I'm going to say it's the original Y, but I'm going to pull out every 1,000th element. All right. So let's do that. Okay. So one thing I'm going to do is I'm going to double check if my T2 and T3 and Y2 and Y3 are equal. All right. How do I do that? I can just use the double equals. And as you can see, I get ones for all 11 elements. All right. So you can check again, T2 is 11, and you can see it over here. So that's good. That means they're all the same. A 0 would mean they're not the same. They're not equal. Okay, and again, should be obvious now, but I'll check Y2, and you can see they're all ones. Okay. All right. Now I'm going to use T3, and I'm going to make a whole new type of plot called a stem plot. All right. So get T3, Y3, and let's do green. Okay, let's run that. Okay. So here you can see the stem plots. All right. Now I'm just doing it on top of them. I can zoom in a little bit. Same thing with both the red and the green. I think they're a little too thin. So let me do line width 2. So run that. Okay. And let's go to the stem, and you're going to see something interesting in a second. 2. Oh, no, it worked. Okay. That is fine. For some reason. Okay. So here's something interesting that I want to show you. So I could have and this is actually a useful thing for making plots look good, is actually each plot has a lot of properties, as you can tell. See, I can change the color, I can change the line width, so on and so forth. So these are just a few of the properties, but let's say you want to look at all the properties. So I'm going to get rid of the green. Actually, I'll leave the green, but I'll change the. I'm not going to put the line width in. Okay, so I run it. It's green. Okay, but what I'm going to do is I'm going to give it what in Matlab is called a handle. Okay, so I'm going to run it, and here you can see a handle has popped out. All right, so I'm going to, in the terminal, I'm going to hit get h1. All right, so look at this list. This whole list gives you a whole bunch of properties that you can change. Okay, so I'll let you read through it, but I want you to see that here's line style, where's line color? It's got to be on here somewhere. Line width is here. Oh, here's color. So this is an RGB, so it'll be RGB, you know, if I wanted to. So what I could do is, let me run it. Let me rerun this. And let me get rid of green. Okay, but this time, I'm gonna, well, let's come back to it. Or let's at least set the line width. So set h1, line width, comma, 2. All right. So here you can see the line width is definitely got changed, but it's still not green. So let me go get h1, and you can see that it is RGB, it's blue. Okay, so let's change it. Let's set h1 color to 0, 1, 0. All right, let's run it. There you go. Okay, so that's some cool little tricks to making some nice plots. All right. Now let's change the font size. Okay. So what we can do is we can go set GCA font size 18. Let's say. Let's try that, and I'll come back to. So there you go. Boom. All right. So what you can do is you can get GCA, and GCA, or even go help GCA. So GCA is it's a handle, just like that H1 was. GCA is the current handle for the axis. So it's get current axis is what GCA stands for. All right. So if I go get GCA, you can see all the different options that you can change by code. All right. So and you can see that here's font size. Okay, so now it's 18. You want to change the font style, yada yada yada. There's a lot of nice a lot of nice properties that on your own you should take a look at. Okay, so that's GCA. There's also GCF. All right, so GCF, help GCF, or actually if I scroll up here, you get a lot of different things. There's GCB. Where's GCF? Oh, there it is. Okay, so GCF is get current figure. All right, so that has other options. So if I go get GCF, you'll find other options. All right, so I'll let you look through that, and that's more on the figure. Okay, now what we need is a legend. Well, of course we need. So we need axis titles. All right, so don't forget that. So let's do X label, time, seconds, and Y label. Let's just say voltage, or V out even, and volts. And that's good. Oh, let's do a legend. Legend, you know, whatever you want to call it. So just plot 1, yeah, plot 1, or let's just do colors. What was it? It was blue, red, green. You can put anything you want. Okay, let's just see what happens. Okay. All right. Well, it looks like actually, first of all, these didn't, this changed, but not the, you can see volts, V out and time are very small. You can see that the font size did change for for the legend, so that's good. So let's do a couple things. First, I'm not happy with this legend being over there. Now, of course, I can move it by hand, but I want to do it automatically. So I can do comma location comma best. All right. Now, of course, you can always do help legend. So you can see it put it in there. It optimized it for you. If you do help legend, you can find a whole bunch of other options. All right. So the other thing is this text size I'm not happy with. So actually what I'm going to try to do, the first trick I always try to do is just put it right into when I call it. So font size 18 and font size 18. Let's try. So the only other the other trick is, of course, is to, and that worked out fine. Okay. The other option is to make handles like I did with the legend. Like H1, I could have called H2. You know, let's just try that for fun. So I'm going to say H2. And let's see if we get an H2. Okay, now let me go to get H2. And you can see that there's our font size. So I'm going to set H2 font size 18. All right. So that did it. Let's see, how far am I? I am 17 minutes in. Okay, I think that's plenty. I hope that helps you being able to plot and feel like you can make some nice plots. All right, I'll see you later.